Hello everyone, sorry for all the hassles, and apparently you have to use a really good adapter for your laptop, otherwise it doesn't work. So this is a session presented by the New York Times developers. And I know this is the last session before lunch. Many of you might already be really hungry. I mean, I'm really, really hungry. And this is also the last day of the conference. Some of you might already be exhausting. So let's try to fight through this together, and hopefully my talk will get something useful for you guys. OK, so today's topic is about Vault Fastly Secret Engine. This is an open source project the New York Times does during the Open Week. So Open Week, it's a yearly event New York Times has for their engineers. So during this week, our engineer doesn't need to do anything about their work. They still need to do engineering stuff, but they can do any personal project. They can talk to their colleagues in other teams to do some brainstorming, do some personal project. They can watch online videos to learn some technology they don't have time to watch. So the really good part is your manager can't put any work-relevant stuff on your plate during that week, unless it's really urgent. So this turned out to be a really successful project during last year's Open Week, and we've been really grateful about that because we finally have time to put on this project to work on it. Forgot to introduce myself. Like Nick said, my name is Ling Zhang. I'm a software engineer from New York Times. I work for the delivery engineering team. And as you can see, there's another name there, Sean Bauer. He is my colleague. He's the lead engineer from the same team I work on, the delivery engineering team. He was supposed to be here, presenting it with me, but why is he not here? This dude called me last week, gave me last-minute notice. He's like, Ling, I'm sorry, my passport got expired. I was like, dude, you're a lead engineer on the Vault team. You work with Vault and secrets every day. Aren't you supposed to be mindful about TTL and expiration? Come on. So I think it's the same idea with the secrets. So it's also probably the reason that people want to start using a lot of dynamic secrets, because they don't want to always pay attention on to expiration date, what the TTL to be set to be more appropriate, and how many tokens you're creating, and where they end up with, how people are using them, where they're putting them. If you're using dynamic secrets, then you don't need to worry about any of this. You create when you need them, and you destroy them immediately after you're done with them. So today's topic will be a really specific use case, how we're using Vault as a platform and to talk to the API to other platforms to create dynamic tokens for usage. OK, let's get started. There you go. This is today's agenda. We're going to first talk about the Fastly current situation at New York Times. We're going to talk about the first try of secret management improvement we did. We're going to talk about pay more attention about the Vault plugin we create, which is the Vault Fastly Secret Engine we create. We're going to talk the design of it and the integration of it, the integration we did to our CI/CD pipeline. And last but not least, we're going to talk about the future plan of it. OK. So the first thing we're going to talk about is the Fastly current situation at New York Times. First thing first, what is Fastly? So for those of you guys who don't know what Fastly is a CDN, which stands for Content Delivery Network. The New York Times started using the election of 2016. So as you guys know, the election of 2016 is a really big change for the US. Same thing with the New York Times. Starting using Fastly is a really big change for our infrastructure and architecture. We've been really happy with this so far. So what is CDN? Just gave a really, I'm pretty sure a lot of people already know what CDN is. So CDN stands for Content Delivery Network. It's a network we put in between the end user and the backend. It protects the backend and releases the pressure for backend by serving the cacheable content. And it improves the user experience by serving the cacheable content from the POP, which is the point of presence, from a closer location instead of serving directly from the backend. And Fastly, they provide more than 50 POPs globally. So we've been really happy with the behavior so far. They also provide a lot of security features like DDoS protection, web application firewalls. The other really important feature we've been using from Fastly is called purge service, which means whenever we want to update the cache content from the edge POPs, we'll be able to purge the cache content from the POPs within milliseconds. So it's either mark the TTL as invalid or delete the cache content directly from the POPs. So it can directly talk into the backend to get the most updated content. So yeah, we've been really happy with Fastly so far. What is the current situation of secret management of Fastly service at the New York Times? So there are majorly two different kinds of tokens we're managing for the Fastly service at New York Times. There are Fastly global tokens and Fastly purge tokens. The global tokens are the one we're using for daily deployment for the Fastly services. So there are currently 32 apps sitting in the repository right now. And for each app, it has 3 environments, known as dev, staging, and production. So for each environment has its own designated Fastly service. So if we create 1 token for each service, so 32 multiplied by 3, there's already 96 tokens we're managing as global tokens. There's also purge tokens. So there are possibly 1 or more purge tokens per service if the team requires it. Some teams maybe don't want a purge token at all, but for the more collaborative service, they probably would ask for more than 1 purge token. So let's say there are 10. There's definitely more than 10. It's already more than 100 tokens we're managing. Since the delivery engineering team, the edge infrastructure team are managing all the Fastly services, so we have to manage all these tokens ourselves too. And today we're going to be mostly talking about the Fastly global tokens, which are the one we use for daily deployment. So just give a little bit more background information for this. This is the CI/CD pipeline we use for Fastly services. As I mentioned before, the apps are sitting in the code base for the apps are sitting in the GitHub repos, and so each one of them has its own designated repository, and we have all the configuration for dev, stage, and production in one repository, and we're using Drone as the CI/CD deployment tools. The same thing with Jenkins or Travis CI. We're defining all the CI/CD pipelines in the YAML file. So for Drone, it's called .drone.yaml file. And the only difference is the Drone is a container-based CI/CD tool. So at each single steps in the Drone YAML, it's a separate Docker container. So we're using Terraform, as most people does, to generate the state file, and we're using Amazon S3 as the backend to store the remote state file, which include the current Fastly service configuration. And we compared the new changes with the current Fastly configuration, and we deployed to the Fastly service. For all the secrets we're using during the pipeline, we were putting them into the drone secret section. And they were sitting in the Amazon RDS. And all this token, they're sitting in there as plain text, and totally depends on the access control of IDS to protect them. So that's not ideal. What's the problem we want to solve here? First, since I mentioned before, Fastly team are managing all these tokens, so we want to kind of consolidate all the tokens. We want to have one single account managing all of them, but there's a limitation for the Fastly account to how many tokens it can have in a Fastly account. There's 100 number of tokens we can have. Apparently, I mentioned before, we're way over the limit already. We've been constantly asking the Fastly support team to increase the limit for us. It's really not ideal. And we need a better place to store the tokens with easy way of managing it. Drone secrets works perfectly with the pipeline, but we're not really satisfied with the plain text part, and we don't want to really totally depend on the access control of RDS to protect it. So we're looking for something like Vault. And we want to automate the process of retrieving tokens from where it's stored during deployment to avoid human operation. So it works fine if we're just using drone secret section, but if we want to use Vault, we want to find a nice way to integrate it with our CI/CD pipeline. And we also want to automate the process of rotating secrets without updating manually everywhere. So that is a problem for us if we use the drone secret section. Because whenever you want to update your secrets, you want to rotate your secrets, you have to manually update them in the drone section. That's really inconvenient, and human operation always make mistakes. So last year, the first improvement we tried for this is we replaced the storage location from drone secret to Vault. And in that way, we solved 2 bullet points from the last slides. First, we find a more secure location for all the secrets for Fastly. we use Vault instead, and we find a nice way to integrate the Vault into our CI/CD pipeline. We use the Vault image in our drone YAML, and we're logging the app in Vault using AppPro, so it can retrieve the tokens during the pipeline when it's needed. But there are still problems. We're still constantly hitting the limitation of tokens in the Fastly account, and we still need to manually update the tokens when we rotate them. So we keep brainstorming, and we finally find the solution for us, which is the Vault Fastly secret engine. So based on the solution we had for the first try, we did a little bit changes. So we were thinking, what if we just use dynamic token instead? We just create the tokens using Vault, talking to the Fastly API during pipeline when we need it, and we dump them immediately after we're done with them. So we will no longer hitting the limitation of tokens in the Fastly account, and we don't have to manually rotate them and update them anymore. So that's what we did with this secret engine. Let's pay more attention of this secret engine we created. There are several design problems we had when we were firstly brainstorming it. So how to programmatically provide the MFA token to Fastly. So Fastly, same with all the other platform or tools you guys are using, they can enable the MFA for Fastly user to log in. And for most, I think for most of companies, they will require their engineer to enable the MFA for security. So that will be a problem if you don't have a way to do this. We don't want to bypass it. We still want the MFA. But luckily, Vault are providing an inbuilt TOTP functionality, which can create the TOTP tokens for you. So that really benefits us. We can just create the TOTP tokens within the plugin and talk to the Fastly API. Second, how to make it easy to use in drone. As I mentioned before, we did find a nice way to integrate the Vault into the CI/CD pipeline. But if we're using Vault, if we're not using the static tokens in Vault, but using Vault as a platform to create a dynamic token, that will be a little bit different. So the thing we do is we compile the Vault image with the Terraform image. So we have a Vault Terraform image. We use this image in the Terraform drone pipeline, so that you can not only run the Terraform command, but also run the Vault API to use the Vault API to create the tokens and export as the environment var, then do the Terraform plan and Terraform apply later. Third bullet point, how to do access control so that tokens are dedicated to only designated service. This is really important. So even though you can create dynamic tokens, you'll be less concerned about the security of the tokens, but you still don't want to let any team to create any tokens for any service. So this is really, really important for us. So when we're designing this, we're doing this for 2 layers. The first layer, we're doing it in the Fastly level. So the Fastly API we're using, we're specifying which service we're actually creating this token for. So when you input the service ID for this service, for the tokens, so the token can only be used for this service. And the second layer is on the Vault level. So in the policy of the Vault, we're specifying which service ID you can use for this Vault plugin API we created. OK, let's take a closer look of how we're designing the plugin. This is a really generic diagram. This is actually a diagram we pulled directly from the documentation the HashiCorp Vault provided online. So that should be really useful for you guys if you guys just looking for create any Vault plugins. So let's work through this. The only thing different from, I think it's different from the other plugin you created for other tools or plugins. You're not writing code directly into the code base of the Vault code. You're writing a separate app, and after you complete the app, you're packing the app together with the Vault base image. You need to register your plugin with the Vault so that you can use it. So in this diagram, as you can see, the first step after you finish the code, you register the plugin with the path and checksum with the Vault. So you generate the checksum and you write into the right path under the catalog of the Vault in order to register it. And after you register it, every time when you use it, Vault will look for the plugin to see if it's already being registered. And it will verify the checksum of the plugin. After it's being verified, it will send and wrap token to the plugin you're trying to use. And after the plugin got the wrap tokens, you can use this, it can unwrap the tokens and use it to set up the RPC server with TLS and communicate the Vault core via RPC over TLS. So that's the generic workflow of how the plugin of Vault works. OK, so here's a snippet of the code of how we get the TOTP token. This is a really important piece for our plugin. So as you can see, in this function called generate TOTP code, we input one string called key. So this key is the shared key. Every time we set up the multi-factor authentication, whatever platform you're using will give you this shared key to set it up. So you will need to input it here in order to generate a TOTP token. So we're calling this function provided by HashiCorp called generate code custom in the TOTP lib. And we're using the key we passed in, the current time, and there's 3 different parameters you can customize here. So the period, which is the TTL for the TOTP tokens, we set it to be 30 seconds. And the digit is 6. I think in most common cases, we're using 6-digit TOTP tokens. But just in case if you have a special use case, you can also customize it. And algorithm, in general, people use algorithm SHA-1. But if you have a special use case, it depends on what platform you're using, what they require, you have to customize it with your need. So it's pretty straightforward, and it's pretty convenient for us. And another really important piece for our plugin is the Fastly API. I know this is a really specific use case, but thanks to Fastly, that it provides this way for us to create the tokens so we can make this happen. This API is actually just providing a TOTP tokens we created from the last slide, the function of last slide. And we're providing the username and password for it so that we can create the tokens. If you don't specify any other field, they would just create a really global tokens for you, which means this token can be used for any services, can be used as global scope. But that's not what we want, but it's OK. We can specify it with service ID. The service ID can be one single service ID or can be an array of services. Just in case if you want your dev stage and production to all share one service key, you can do that. And the scope can be global, which is the one we're going to use for we usually use for the deployment. It can also be purged. So purge select or purge all depends on if you want to purge one single URL or you want to purge everything for your service. And for the TTL, it's optional. We have a default 5 minutes TTL for those tokens we created because usually 5 minutes is pretty enough for all the deployment we did for the Fastly services. But just in case if you need a longer one, you can also customize it. So that's the Fastly API. Now let's do a demo for it. Let's prove that what I just said is not bullshit. How do I exit it? There you go. OK. I have this cheat sheet here. Oh, sorry. What is that? Oh, no. Can someone help me with it? I can't see my mouse. Looks like it's being mirrored, so it's not being mirrored, though. I don't see the.
Yes.
Wait. Can you come back? I want it to be mirrored. Do you know what I mean? So I want to show this exactly there so I can operate it here. I'm sorry about that. Yeah, just to mirror. Yes.
Hey.
Thank you. Thank you for your patience, too. OK, there you go. So before I start the magic, like any other magic you've seen, I have to show I have an empty hand. So this is an account I created just for this demo. I refresh it just to show that there's no tokens in this account yet. OK, there's only one token. This is the one Fastly created just for this browser session. OK, let's start the magic. I have a terminal window here and a cheat sheet here. So I'm just going to run this Docker command to use the binary I already compiled. I already built. So just to give you guys some information here, all I did before this step is just use go build and use Docker to create this binary. And we call it a Vault plugin. That's it. To save us some time, so we don't need to build it here. And as I mentioned before, for Vault plugin, we compile the base Vault image with the plugin code we created. So in this binary, it has the Vault base image and also the code of the plugin created. OK, let's run this command to spin up a local Vault. So this command is the one I directly pull from the HashiCorp Vault website. It runs a dev mode Vault for us, so we don't need to unseal it. As you can see here, dev mode is enabled in this mode. Vault runs entirely in memory and starts unsealed with a single unsealed key. OK, great. And we're naming this token to log into this Vault called myroot. And as you can see, it's a local Vault. We're using 123.4 port for it. And we're using the image called Vault plugin we just compiled. All right, so we have a Vault. Right, we have a Vault now. Let's try to use it. The first thing first, we want to specify which Vault we're using. We're telling the terminal we're using this 1234 port Vault. And we want to log into it using the token we just specified. There you go. We're in the Vault. And for the first time using, we want to configure the plugin in this binary with the Vault we're using. So as I mentioned before, you need to register this plugin. The thing you do first, you need to create a checksum for your plugin with this command. And let's verify if there's really a checksum there. Look like there is. And then we're going to register the plugin by writing this checksum into the sys/plugin/catalog/Vault Fastly secret engine, so that the Vault we're using will know this plugin is there. Success. Great. Then we're going to enable this pass for this plugin. So all it does for this command is just telling Vault whatever field or flags send it to this Fastly/pass will directly talk to the plugin that we just registered. And as you will see in the following step, there's subpath we define in this plugin, like config path is the one we're using to map into a function in the plugin we write to collecting all these credentials for the Fastly API we're going to call for. So in this step, so in the following step, I'm going to configure this plugin with the Fastly credential. I don't want you guys to know my password, username, or share key, so I just wrap them up into a shell script. I'm just going to run it. Here we go. We write everything into the Fastly config. So now the plugin knows which username and password we're using for all the API calls. OK, looks like all the plugins being configured. Let's try to see if it's really working. Let's try to make a token for it. So for this demo, I created a really fake service called test. And it's inactive because I didn't set up any backend for it. But it's fine. We're going to just use that to create a token for it. OK, looks like the service ID is already there. We're just going to use this one. So in this command, we're using Vault write Fastly/generate, and we specify the scope to be global, the service ID to be the one of this test, the fake test service here. There you go. We got a token. Let's verify it if it's really there. There it is. OK. Not yet, not yet. I'm going to give a little bit more information because as you can see, it's saying this token's being created at July 10th, and it's expiring July 10th. We don't know what exactly the the TTL is. There's a Fastly API we can use to verify it. OK, so I'm going to just passing the token we just created here. Boom. OK, so this token's being created at this time. I'm pretty sure it's not the same time zone with us. And it expires in 10 minutes after that, which is, as I mentioned, we have 5 minutes default TTL. And as you can see, the name matches the one we see in the UI called the Vault Fastly Secret Engine. We kind of hard-coded in the plugin. And the scope is global, as we define. You cannot see the service ID because it's a fake service. It's inactive, so it's not showing here. OK, great. It's working. Let's go back to the slides. We finished the demo, droning on. So after we finish the plugin, we want to pack it together into binary and send it to GCS so we can use it in other deployment pipeline. Yeah, as I mentioned before, we're using drone in all the deployment at New York Times. So this is just a snippet of drone YAML we're using to build the image, build the binary, and deploy it into the GCS bucket. As you can see, the image we're using was Golang 1.9 Alpine. We want to keep it as light as possible, so the pipeline will run as fast as we can. Yeah, just do the Go build and defining some Go environment vars. And in the deployment step, it's just providing the Google credentials, which have the right access to push the binary into the GCS bucket. Then we're going to talk about the integration of this. How do we really integrate this plugin into the drone pipeline we're using? So there is a snippet of how we create the Vault tokens to log into Vault. So in order to use Vault in all the steps in drone YAML, we have to, at the really beginning of the drone YAML for any service that want to use Vault, we have to log into Vault. We have to create a token so that you can log into Vault in the following steps. So we're using AppRo to do that. In order to log in order to generate the Vault token with AppRo, as you guys might know, you have to provide the role ID and secret ID. We're providing the role ID in the environment var, and the role ID are being provided in the anchors in the common secret section. So we put them separately just to be more secure. And we're specifying the Vault address. This Vault address should be the one that you have the plugin configured and registered already. And in the command, you're actually just running this command to create a Vault token that you can really log into the Vault in the following step. And you're putting into the root folder, so you can actually be shared between different pipelines. So after you did this step, you should be able to use Vault. OK, there we go. So this is just an example of how we're using Vault in the deployment step. The image we're using, as I mentioned before, is the Vault Terraform image. It has the ability for you to be able to not only run the Terraform command, but also the Vault command. So this is the same thing we did in the demo. We're using this Vault write View token Fastly generate thing to generate the global token for this dev service. And we export it. We export this token we generated as Fastly API key, so we can use this Fastly API key in the following command. You can use that to do the Terraform plan, Terraform apply. All right. So let's talk about the future plan for this. To infinity and beyond. Open source. So last time when I talked about this, we are not being approved by the InfoSec in our company to do this as an open source. But now we're being officially called open source project. Yay. And we're going to soon post our blog post about this open source project we did at open.newyorktimes.com. We will publish it really soon. And I really recommend you guys to take a look of this website, because there's tons of really interesting stuff that engineer at New York Times does. And And we want to think about creating a drone plugin. So as you can see in the drone YAML I showed you guys, we're still doing a lot of command lines. So in that way, it could be really tedious in showing the drone YAML. We don't want it to do that. We want the drone YAML to be more readable, to be cleaner. So we're thinking just to pack everything together, and in the future, the user can just pass in all the parameters as fields in the plugin. And to integrate the TOTP functionality in Vault to something other than Fastly. So as I mentioned before, Fastly is really just a specific use case that how you're using Vault as a platform to talk to the API of another platform to create the dynamic tokens for your pipeline. But we really want to use this as a start and started to use more dynamic tokens in other use cases at New York Times. And in that case, we don't have to deal with the secrets, expiration dates, TTL, stuff like that. So we won't have the same problem like what my colleague Sean had with his passport, I guess. All right, so that's it. Thank you.